Hi dear students, today in this video I am going to discuss the second part of the chapter number 6, combustion and flame. Here the main topics we are going to discuss that are the details of the flame and the fuel. So let's start with the flame. A flame is a luminous mixture of gases undergoing combustion. It's a mixture of the luminous gases means which produces light. That means during the combustion, when a combustible substance vaporizes, it produces flame. The substance which vaporizes during the burning gives flame. For example, kerosene oil. You can see here, this is the flame which is produced by kerosene oil, and this is a hot gases. Then there is another possibility that is the substances which do not get vaporized do not produce flame. For example, coal. You can see here this picture, that is coal is burning here, but it does not produce flame because it does not get vaporized. I already said that flame is a mixture of hot gases. That means the combustible substance should get vaporized to produce the gases. And when these gases release light, because of its high temperature, it makes flame. So this is the things you have to remember. The substances which vaporize during burning, which gives flame. The substances do not get vaporized, they do not produce flame. So that is the difference here. This is actually the burning of coal and this is actually burning of kerosene. So this is all about the basic idea you need to understand. What is a flame? We will discuss the structure and the different parts of the flame in detail later. Now let's classify some substances into those who produce flame and does not produce flame. Table 6.1 I am taking here, which is given in the textbook. In case of candle form flame. In case of magnesium, that is already we have done an activity. You have seen a white flame there. Camphor also produce flame. Kerosene oil also I already discussed in the introduction part. In case of charcoal, that does not produce flame. Charcoal, coal, such types of substances do not produce flame while it burns. Let's discuss the structure of the candle flame here I am taking to understand the details of the flame. See here, the outer part is the hottest part. That means high temperature. And why it is become hottest part? Because the complete combustion of that fuel take place. Because of that, the color of the flame is blue. Clear? I already told you regarding complete combustion and incomplete combustion in the last video. Now moderately hot, that means at medium temperature. Here it is middle zone, that is undergoing partial combustion. Its color is yellow. That means it will be moderately hot. I already told in the last video that is for the same fuel, if it produces blue and yellow or red flame, then blue flame indicates complete combustion and red or yellow flame indicates partial combustion or incomplete combustion. Same way here also. And the least hot in that area is actually innermost zone of unburned wax vapors. So what exactly happens is that while it is during the igniting of this candle, this solid candle wax will be melted and to convert into liquids. As the temperature increases, again this can be converted to vapor. Here it is actually unburned wax vapors. Okay, when it goes up, slowly it will start to burn. And here it is incomplete combustion or partial combustion. While it comes to the outer part, it has more contact with the oxygen, or it has the easy contact with the oxygen, so it leads to complete combustion of those vapors. Because of that, the outer part of the flame will be blue. While you're observing the candle flame practically, you can only observe the outer part of the top portion will be somewhat blue, but not the whole part here. Okay, as shown in the figure. So this is all about the structure of a flame. That means we can conclude outer part of the flame is more hot than inner part. So this is the reason why goldsmith like that people are using the outer part of the flame for melting gold and such types of metals, because the outer portion of the flame or outer layer of the flame is the hottest part. So this is the very important thing you have to remember, and the structure of the flame also. In the last section, I told you that substances can be classified into combustible and non-combustible substances. What are the combustible substances? The substances which undergoes combustion. But all the combustible substances are not considered as fuel. Or even though they can be burned, but still they are not considered as fuel. Only certain types of combustible substances are considered as fuel. That means the substances are used as a source of heat energy for domestic and industrial purposes, that are wood, charcoal, petrol, diesel. These all are fuels. But some combustible substances like our clothes, dress, these materials or these substances we are not using as a source of heat energy for our domestic or industrial purpose. But still these substances can be burned. That means all the combustible substances are not considered as a fuel. The substances which are used as a source of heat energy for burning, only such types of substances are called fuel. Like fossil fuels we have discussed, this petroleum, natural gas, coal, these all are fuels. And what are the characteristics of a good fuel or ideal fuel? First, let's see that a good fuel is readily available. That is the first characteristic. That means it should be easily available. Second one is it is cheap. Economically, it should be cheap. It should not be very costly. And it burns easily in air and at moderate rate. It should be burned easily. That means its ignition temperature should be low or at moderate. And it burn at moderate rate. That means not too slow, or it should be like plastic. At a moderate rate. And it produces large amount of heat. While burning is even a small amount of substance, it should give somewhat significant amount of heat. And it does not leave behind any undesirable substances. Suppose we are going to burn plastic. Plastic is a combustible substance and it produces heat, flame, light, everything. But after burning, after completing of the burning of the plastics, you can observe that it leaves some undesirable materials in that place. That means it cannot be used as a fuel, or it is not the characteristics of the good fuel. So these are the some characteristics you have to understand which affect the quality of the fuel. So while we choosing a fuel, we have to look at these characteristics. If a fuel or substance follow these characteristics, then we can take that as a good fuel. And the another important characteristic, that is calorific value. So calorific value, the amount of heat energy produced on complete combustion of 1 kilogram of a fuel is called its calorific value. It is expressed in the unit kilojoule per kilogram. What is the meaning of this? When we burn 1 kilogram of a substance, what will be the amount of heat energy produced? That will be the calorific value of the fuel. Simply the amount of heat energy produced by 1 kilogram of that fuel. That will give a calorific value of that fuel. For different types of fuel, the calorific value is also different. We will discuss the calorific value of some substance later. And so we can make a mathematical expression for the calorific value, that is calorific value is equal to amount of heat energy produced divided by mass of fuel burned. Total energy released divided by total mass. We will get the heat energy released by 1 kilogram. That is the calorific value. Its a unit is kilojoule per kilogram. For example, we can say the calorific value of petrol is 45,000 kilojoule per kilogram. That means, what is the meaning of this? When 1 kilogram of petrol is burned, 45,000 kilojoule energy is released. Actually, joule is the unit of energy. Kilojoule means 1000. 1 kilojoule is equal to 1000 joule. So we can say in two ways. When 1 kilogram of petrol is burned, it releases or it produces 45,000 kilojoule. Or when 1 kilogram of petrol is burned, it produces 45,000 into 1000 joule. Because when kilojoule converted into joule, it will be this much amount of joule will be released. Joule is the unit of energy. Like a meter is the unit of length. Clear? So this is all about the fuel and the characteristics of fuel and calorific value. Let's discuss some numerical examples to get the clear idea about calorific value. Okay, first example that is given in your textbook, exercise question number 11. Here, in an experiment, 4.5 kg of fuel was completely burned. The heat produced was measured to be 1,80,000 kilojoule. Calculate the calorific value of fuel. So, first quantity given, that is mass of the fuel. Mass of the fuel burned is equal to 4.5 kilogram. 4.5 kilogram. And the heat produced, amount of heat produced is equal to 1,80,000 kilojoule. Then what is the formula we have to find the calorific value? This is the formula we have, that is calorific value is equal to amount of heat energy produced divided by mass of fuel burned. That is, what is the amount of heat energy produced? 1,80,000 divided by what is the mass of fuel, that is 4.5 kilograms. So kilojoule per kilogram. Kilojoule is the unit we are putting for energy and kilogram is a unit for mass. That is equal to 1 decimal point is so to eliminate decimal point, multiply multiply both the numerator and denominator by 10 into 10. Here also 4.5 into 10, which is equal to 18. How many zeros are there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 divided by 4.5 into 10 is equal to 45. Now considering only this 180 and 45, what is 180 divided by 45, which is equal to 4? Am I right? 45 into 4 is equal to 180. Now how many zeros remain here? 4 zeros. 1, 2, 3, 4. So final answer is 45,000 kilojoule per kilogram. This is the calorific value. Let's take one more example. Second example, that is in an experiment, 3 kilogram of fuel A, that is the first quantity. Mass of fuel A is equal to 3 kilogram. And 14 kilogram of fuel B, that is mass of fuel B is equal to 14 kilogram. Was completely burned. The heat produced was measured to be 7,12,500 kilojoule. So heat produced is equal to 7,12,500 kilojoule. These are the three quantities given. Now come to the first question. If the calorific values of fuel A and B are in the ratio 8:1, calculate the calorific values of fuel A and B. So here we cannot directly go for like what we have done in the previous example, because there was only one kind of fuel and all the out of two quantities were given. But here the heat was given that for the heat energy produced by both fuel A and B together. So we cannot directly find it separately by using this heat energy. So here we have to set up a variable, or we have to form a linear equation. For that, we need to write the equations or steps in terms of the calorific value, because in the question the ratio between calorific value is given. So we need to modify the basic formula what we have. This is the basic formula we have, that is calorific value is equal to amount of heat energy produced divided by mass of fuel burned. That means if we bring this denominator term from RHS to LHS, it will become on numerator, or divided by mass of fuel burned will become multiplied by mass of fuel burned. So that you already learned in mathematics how to transpose the term from LHS to RHS. I am not going to discuss that one. So this equation will be modified into the form as shown here. That is calorific value into mass of the fuel burned is equal to amount of heat energy produced. So we have to, after setting up this in this form, we can easily go for solving the question. Before going for solving the question, we have to set up the variable that the unknown quantity given here are calorific values. For that, here ratio is given, so we can set up the variable like let the calorific values so fuel A, I am not writing fuel A, right? I am just writing A only. A and fuel B. Now, how to put the 8:1 in terms of the variable? You already learned in linear equation in one variable in your mathematics. So recall those things here also, that if the ratio of two quantities were given, we can put that two quantities in terms of the variable by multiplying the corresponding ratio by a variable. Like 8:1, we can put like 8x and 1 into x is x. So the calorific values, we assigned it as 8x and x from the ratio 8:1. Now we can go for solving the equation. That what is the conditions given in the question? According to the question, that heat energy produced, total heat energy produced is equal to heat energy produced is equal to 7,12,500 kilojoule. The total heat energy produced will be heat energy produced by fuel A plus heat energy produced by fuel B, which is equal to 7,12,500. What is the heat energy produced by A? Heat energy produced by A will become calorific value of fuel A into mass of the fuel A. This equation we are going to substitute here. Okay, the heat energy produced is equal to calorific value into mass of the fuel. What is the calorific value of fuel A? We assigned it as 8x, because we assigned as fuel A is 8x and B as x. Clear? So 8x into, what is the mass of the fuel A given in the question? That is 3 kilogram. Okay, plus now heat produced by B, that is equal to calorific value of the fuel B. What is the calorific value of fuel B we assigned? That is x into mass of the fuel B, that is 14 kilogram, which is equal to 71250. Just keep it, nothing to change here. 8x into 3 will be 24x plus x into 14 is equal to 14x. I am not going to discuss how to solve the linear equations because you already learned in mathematics detail. So I am just solving, just understand the steps. And 7,12,500. Now 24x plus 14x is equal to 38x, which is equal to 71250. Therefore, x is equal to 71250 divided by 38, which is equal to, numerical calculations you can try yourself. I am directly writing the answer here, 18,750. So, calorific value of fuel A is equal to 8x. Okay, 8 into x. What is the value of x we got? 18,750. So numerical calculations you can try yourself. That is 1,50,000. This is the answer we will get on multiplication of 8 into 80,750. Clear? That you can try yourself. And similarly, calorific value of fuel B is equal to x. according to our assigned variable. So that is equal to, what is the value of x? 18,750 kilojoule per kilogram. So only this much you have to remember. Now the second question is identify the fuel A and B. To identify the fuel A and B, we are going to take the help of table 6.4 given in the page number 73. See here, calorific value of fuel A is 1,50,000. So which will be the possible fuel? That will be hydrogen. So fuel A will be hydrogen. And 18,750 is the calorific value of fuel B. So in which range? I think this. Yeah, this is the value. That means 18,750 will become between 17,000 and 22,000. So the fuel will be wood. So these are the two fuels. So we solve these questions. Okay. So these types of questions are very, very important. Let's see the table 6.3, that is fuels are in different states. Some fuels are solid, some fuels are liquid, some fuels are gaseous. Coal, wood, charcoal, these all are solid fuels. Well, kerosene, petrol, diesel, all are liquid fuels. Natural gas, LPG, biogas. Even though LPG stored as liquid, but its natural state is actually gaseous state. Okay, so these are the examples for different kind of fuels. This is also, just to remember, it's very important. Till now we have discussed only the positive aspects or the merits of the fuel and combustion. Now, if we are going to increase the burning of the fuels, what will be the effect or how it affect the environment? That is what we are going to discuss. How increasing fuel consumption affect the environment. First way is that carbon fuels like coal, petroleum release unburned carbon particles to the atmosphere. It leads to air pollution. Because we know that it's not possible to make an ideal fuel which can be burned completely. Whatever the fuel we are taking that, even though if we say that some fuels are good, it does not leave any unburned particles behind, but still it releases. Especially in the case of fuels like coal, petroleum, because which consist of carbon. During the combustion of the carbon or burning of the carbon, some part of this carbon fuel goes for the incomplete combustions, which leads to the releasing of the unburned carbon particles in the atmosphere. This is the one way how increasing fuel consumption affect the environment, and it leads to the air pollution. Second is that incomplete combustion of this fuel gives carbon monoxide gas. I already discussed in the first part of this chapter that during the incomplete combustion of carbon monoxide will be released. Suppose if the incomplete combustion takes place continuously, it leads to the accumulation of carbon monoxide gas in the atmosphere, and which is a poisonous gas, so it affects the environment. And third way is that combustion of most fuel releases carbon dioxide in the environment. Almost all the fuel consists of carbon, and even during the proper combustion, it produces carbon dioxide. If the carbon dioxide gases is released in the excess amount to the atmosphere, it accumulated in the atmosphere. And this accumulation of the carbon dioxide gases leads to the global warming and due to the increased rate of greenhouse effect that we will discuss in the later chapters in detail. So this is the another effect of the increased fuel consumption on the environment. And the last thing is that burning of coal and diesel releases sulfur dioxide, and burning of petrol releases oxides of nitrogen, which result in the acid rain. We know that burning is a reaction with oxygen. So petrol and diesel consist of sulfur and nitrogen. So when it reacts with oxygen or it burns, it forms its oxide gases. Like carbon react with oxygen, it forms carbon dioxide. Similarly, sulfur react with oxygen, it produces sulfur dioxide. Similarly, nitrogen react with oxygen, it produces oxides of nitrogen. So it leads to the acid rain. How it is formed? Like let's discuss in detail. That is, see here, sulfur dioxide, SO2 is actually sulfur dioxide and NO2 is oxide of nitrogen. These two gases will be released during the burning of diesel and petroleum like that fuels, and it is goes to atmosphere. And this during the evaporation of the water droplets also go to atmosphere. It mixes with the water in the clouds and it forms H2SO4 and HNO3. H2SO4 is a sulfuric acid which is formed by H2 water and sulfur dioxide. And HNO3 nitric acid is formed by combination of water and nitrogen oxide. Okay, and this two water will come with a rain. That is called acid rain. So this is the way how acid rain formed because of the increased fuel consumption. And acid rain affect the fertility of the land and it affect the plants, aquatic animals, etc. It affect whole environment. So this is all about the chapter combustion and flame. So I'm going to conclude this chapter with this video. So this is the time for winding up this video. So in the next video, I will discuss another chapter. So that's all for today. Thanks for watching.